Good morning. Listen now. This is yesterday's class summary that I supposed to do it first. Then I will take up the today's portion. The first concept. Okay, digital electronics. Digital electronics. What is that concept here now? I told you yesterday. Nowadays, everything is digitalized. All the signals are said to be the digitalized signals. Signal can be divided into two categories. This is old concept, that is analog signal. The new concept, digital signal. Analog signal, it varies from 0 to maximum. Any fraction it can vary. Bit by bit also it can vary. It can change, it can vary from 0 to a maximum value. Anywhere else, it can take the values. But digital circuits or digital signals are not like that. It is having the discrete values. Digital signals are having only the two discrete values. Either it is 0 or it is 1. Okay. Either it is 0 or it is 1. 0 means all these concepts are holds good. Maybe low voltage, circuit is not working, no voltage, low voltage, no voltage, not working, false. Okay. It is off condition. It is off condition. This is on condition. On. Circuit is on. Circuit is off. Circuit is containing high value. It produces a high value. It says that yes, there is a voltage. The circuit is working. The statement is true. Like that, we are going to consider for 1. Okay. Our computer, our mobile phones, if we are feeding something in the form of text, then all the text is converted in the form of 0 and 1. Then it has been sending. At the receiver end, that 0 and 1, it has converting back in the form of the analog signals. Okay. So now, what are logic gates? Logic gates, they are the building blocks of a digital circuit. If you are taking any digital circuits, it is made up of some basics gates. Those gates are called by the name logic gates. Okay, just like an element is made up of its own smallest particle called by the name the atoms, like that. So logic gates are the building blocks of digital circuits. In the case of logic gates, we require Boolean expression and we require truth table. Boolean expression means for any logic circuit, we are giving some input and we are taking some output. Input to output, whatever we are giving, whatever we are taking outside, we are taking out. The input to output, there is a relation. That relation is called by the name Boolean relation, that is represented by an equation, an expression called by the name the Boolean expression. That Boolean expression, either it is true or false, that it has been verified by using a truth table. This is also important. This is also important. Okay, first one, under the logic gates. Logic gates, according to your syllabus, it has been divided into OR gate, AND gate, logic gates, OR gate, AND gate, NOT gate, NAND gate, and NOR gate. NAND gate and NOR gates, they are called by the name universal gates. These two are called by the name the universal gates. By using a many number of NAND gates, we can produce the OR gate. By using the number of NAND gates, we can produce the AND gate. By using a number of NAND gates, we can produce the NOT gate. These are the practicals we are doing in the case of higher classes. Okay, you have been given the NAND gates, then verify the OR gate. You make the circuit so that it is acting as an OR gate and verify the truth gate. Like that we are asking in the case of practicals. Not for you, of course. For you people, you are having only these many, not this. Okay, what is that OR gate concept? OR gate means, again, here, first of all, we have to think in this chapter, how many marks we are going to ask, what type of questions we are going to ask. If you understood that much, then it's okay, no problem. Here we are going to ask anywhere else either 1 plus 1 mark or maybe anywhere else we are asking for 2 marks question. So think for 2 marks question only. OR gate. First 2 marks question. Write the circuit symbol for OR gate. We are asking. Write the circuit symbol for OR gate. This is the circuit symbol for OR gate. If you are writing this much, you will get 2 marks. Now, the OR gate which is containing 2 or more inputs. Higher classes, we are putting even one more input also we are putting here. A, B, C is the third input. 3 inputs, 1 output. But here, 2 input circuit I have written. We have given 2 inputs and we are getting 1 output. The output is represented by Y is equal to A or B. So plus sign indicating R, A or B. This is Boolean expression for OR gate. Now, the truth table. How the truth table it works? How the truth table we are going to write. There are 2 inputs here, A and B. There is only one output, that is Y. Y is equal to A plus B, that is A or B, like that we are pronouncing. And the options we are supposed to write for the inputs. Inputs we have to write the options. The options are 0 and 0, 0 and 1, 1 and 0, both are 1. Then 0 plus 0 is 0. 0 means it is off condition. It is not working. Voltage is very low. 0 plus 1 is equal to 1 means it is working. It is on condition. 1 plus 0 is 1. It is on condition. 1 plus 1, you should not write 2. Either it is 0 or it is 1. Either it is 0 or it is 1. Yes plus yes, you should not say that one 2 times yes. No, yes only. That's all. Yes plus yes, it is yes. On and on, it is on only. So therefore, 1 plus 1, it is equal to 1 only. That is output. This is for the OR gate. Okay. Next one, AND gate. What is that concept of AND gate here? AND gate also we are asking 2 marks question. The whole topic we are asking for about 2 marks question. Write the circuit symbol for AND gate, 2 marks. If you are writing this much, you will get 2 marks. This is a circuit symbol for AND gate. Here also, either there are 2 inputs or I can put one more input also. 2 or more inputs are there here. 2 or more inputs. But output is equal to only 1. Only 1 output. But here we are having 2 or more number of inputs. We are getting only 1 output. So output Boolean expression is Y is equal to A and B. The dot representing multiplication, logical multiplication this is. The dot representing logical multiplication, not an ordinary multiplication. Y is equal to A and B. A and B. A and B. Like that we are pronouncing. Write the truth table for this. Inputs. Again here I have taken the 2 inputs. If I have taken the third input, that also we have to take C. That also we have to write. That is a little bit more complicated. Okay, A, B. Output is A dot B. Means A into B. Means A and B. Both are 0. Any one input is 1. The other input is 0. Both the inputs are 1. Options I have written here. Then A into B, 0. 1 into 0, 0. 1 into 0, 0. 1 into 1, 1. So therefore, this is on. In all the 3 cases, it is off. So therefore, in this case, one more question. If both the inputs are 1, then only the output is 1. If both the inputs are 1, then only the output is 1. Whereas in the case of your, the OR gate here, it is not like that. If both the inputs are 0, then only it is 0. If any one input is 1, then the output is 1. So be careful about this. Okay, coming back to the next gate here, AND gate is finished. Now the NOT gate. Okay, NOT gate, it is also called by the name the inverter gate. It is acting in a reverse way. Okay, inverter it is. Okay, inverter. At home we are using the inverters. Whenever there is no power, inverter will be working. Whenever there is the main current or maybe the KV source, if it is coming, then inverter is going to get off. It is not going to get to switch down. Whenever the main circuit is broken or main current is going to get absent, Inverter, it starts to work. Current, if it is given, it will not work. Current, if it is not given, it will work. That is a NOT gate. Yesterday, I told you about that. Okay. If I'm saying that one, 8 o'clock exactly, you must be there in front of your online classes. No, sir, we will not come. Don't come exactly at 8 o'clock. We will come and sit. That is a NOT gate. That is a NOT gate concept. Symbol. This is the circuit symbol, carries 2 marks. If you are writing arrow mark here, a big arrow mark, one bubble, don't put the dot. It is a bubble you have to put. Then only it is called by the name the NOT gate. Only one input, one output. This is the particular gate which is containing only one input. In all the other gates, it is containing 2 or more number of inputs. Mention a gate which is containing only one input. Not. Now, this is Boolean expression, output. Truth table we have to write. Input, we are having only one input. Only one input, A. Y is equal to A bar. Y is equal to A bar. Now, if you are giving 0 as the input, it is on, 1. If you are giving 1 as the input, it is taken as 0, off condition. If you are giving the input as 0, it will work as 1. If you are giving the input as 1, it will not work. It is acting as 0. So up to here, yesterday I explained. Up to here, yesterday's concept. Now today's concept. What is that? What is that today that we are supposed to learn? Okay, listen. NAND gate, first gate, today's gate. NAND gate. NAND gate, it is a combination of AND gate and NOT gate. You must be aware of AND gate and you must be aware of NOT gate. Both the gates, if you know, then only we can understand the NAND gate. So NAND gate is a combination of, it is a combination of AND gate and NOT gate. An AND gate and a NOT gate together, one after the other, together, it is acting as a NAND gate. Okay. It is an AND gate followed by a NOT gate. AND gate followed by a NOT gate, it is acting as a NAND gate. Now, what is that? How it is said to be? Look at the concept. First, it is said to be a NAND gate. I mean, AND gate, I supposed to write it here. This is AND gate. I'm writing an AND gate now. This is an AND gate. 2 inputs. One input A, the other input B. 2 inputs. The output of this is taken as the input for the next gate. The output for the first gate, the output of the AND gate, we are treating that one as the input for the NOT gate. What is that? What is that? Just to see here. This is NOT gate. Already we have understood about the NOT gate. This is a NOT gate. You are aware of NOT gate now. This is NOT gate. Okay, this is AND gate separately. This is NOT gate separately. Now, this is the input for the NOT gate. This is the output of the AND gate. AND gate output, I will feed that one to the input for the NOT gate. So I will put it like this. So meaning the output of the AND gate, it has been feeding as the input for the NOT gate. This is said to be the grand output. Grand output means all together. Now, AND gate output, I suppose to write first AND gate A and B inputs. Output for the AND gate. Output for the AND gate is A dot B. Multiplication. A and B. A dot B. Multiplication. Logical multiplication. This is intermediate output. This output we are feeding for this NOT gate as an input. These two are input for the AND gate. This is output for the AND gate. This is input of the NOT gate. Input of the NOT gate is output of the AND gate. Now, we are taking out as an output here. This output, I can write y is equal to grand output, y is equal to a dot b bar. A dot b bar, this is the explanation I have given. Now, altogether, if I want to write the circuit symbol, for example, for 2 marks question, we are asking, write the circuit symbol for NAND gate, we are asking. Not necessary to write all these things. Directly, we have to write AND gate followed by a NOT gate. So that can be written like this. This is a AND gate, 2 inputs, and I am putting a bubble here. Then I will take an output. This is output, y is equal to a dot b bar. A dot b bar. Okay, that we are writing. This is output. This carries 2 marks. If you are writing this much, this carries 2 marks here. Okay. So what is that? Circuit symbol. If you are writing this much, it carries 2 marks. A is a input. B is another input. Y is equal to a dot b. Y is equal to a dot b bar. That is for the output for this NAND gate. NAND gate circuit symbol. Write the NAND gate circuit symbol. This is the circuit symbol for NAND gate. These two are input. This is output. This is Boolean expression. Now we are supposed to understand about the truth table now. So what is that truth table? How we are going to write the truth table? Truth table. How we are writing? Truth table, there are 2 inputs. 2 inputs, 1 output. So I will write like this to make you to understand all the steps. I will write it carefully. You see that based on this one only, CET or NEET examination, we are asking for 1 mark questions. Complicated circuits will be given. What is the net output we are supposed to determine? Okay, what is the truth table? Just you see that. This is input. We are having input, 2 inputs, A and B. See the tabular column, 2 inputs, A and B. And then we are having output here, intermediate output. I will show it again, intermediate output, which is that intermediate output A dot B, grand output A dot B bar. Okay, so here, intermediate one, I will write like this. This is intermediate one, A dot B. We don't want this actually, but without that we cannot proceed. Now the output. Now the output I will write. Output Y is equal to A dot B bar. Okay, this is tabular column. This is a tabular column. How we are going to write? So here, options number 1. 1, 2, 3, 4 options. Easy, digital electronics is very easy. Okay, options, both are 0. This is 1 and 0. This is 0 and this is 1. Both are 1. These are the options. Without this, we cannot take the 5th option. 5th option is not existing. Only 4 options we are having. So intermediate output, that is AND output. AND gate output, first we have to write 0 into 0, 0. 0 into 0 is 0. 1 into 0 is 0. 0 into 1 is 0. 1 into 1 is 1. This is intermediate. Now grand output I supposed to write. This is a net output. Net output, this reciprocal. Reciprocal in the sense you should not say that 1 by 0. No. 0 is there. 0 means it is off. Off becomes here it is on. This is on. 0 is there, therefore it is 1. This is on condition. 0 is there, therefore this is 1. This is on condition. 1 is there, therefore the output is equal to 0. This is off condition. This is the concept you are supposed to learn. Any doubt is there within this, you can ask. About the NAND gate. NAND gate is a universal gate. This is a NAND gate. NAND gate means an AND gate followed by a NOT gate, AND gate followed by a NOT gate. AND gate output A dot B. That output A dot B bar. These two together we are writing with a circuit symbol like this. AND gate with a bubble, if you are writing, it becomes NAND gate. Okay, this is the truth table. So we are asking 2 marks question. In this case here, you observe that in this case, in the case of a NAND gate, 1 mark question. If both the inputs are 1, then the output is 0. If both the inputs are 1, then the grand output is 0. If both the inputs are 0, 1 more question, if both the inputs are 0 for an NAND gate, I'm talking about NAND gate. For a NAND gate, if both the inputs are 0, what is the output? You must be aware of all these things. Okay, just to go through this, I will take up the last gate, that is NOR gate. Today I will send the notes for all these things. Okay, finished. Just listen now. Next one. Next one, NOR gate. NOR gate. Now already you got about the concept regarding the NAND gate. Similarly, it is NOR gate. NOR gate, first it is containing this NOR gate. It is made up of, it possesses a NOR gate which is containing an OR gate followed by a NOT gate. It is a combination of OR gate and then NOT gate. OR gate output we are feeding as the input for the NOT gate. Output of the OR gate we are feeding as the input for the NOT gate. That is NOR gate. How it is? Explanation first. OR gate I will write. This is the OR gate. Okay. This is a circuit symbol for OR gate. 2 inputs, A and B. This is output. This is output. This is OR gate. Now I will write NOT gate here. If I'm writing a NOT gate, I can show it like this. This is the NOT gate. Separately, this is OR gate. This is NOT gate. OR gate output is A plus B. A or B. A or B. A plus B is the output. Output for the OR gate. Output for the OR gate. This output I will feed as the input for the NOT gate. Output of the OR gate we are supposed to feed as an input for the NOT gate. So I will put as an input like this. Now the grand output of this Y is equal to A plus B bar. Y is equal to A plus B bar. This is the grand output. If they're asking for the circuit symbol, not necessary to write all these things. This is only for your explanation purpose. Okay. Explanation is also important. Don't forget. For your competitive examination, without these ideas, we cannot proceed. Circuit symbol. If they're asking for 2 marks, write the circuit symbol for NOR gate. Together we have to write. How we are going to write the circuit symbol? This is the circuit symbol. This is circuit symbol. Okay, there are 2 inputs. There are 2 inputs, A and B. And bubble I supposed to write here. This is a bubble. This is output. This is output. Okay. Output is represented by Y is equal to A plus B. A plus B bar. Y is equal to A plus B bar. That is an output. A is an input. B is an input. Then the grand output is A plus B bar. It is a grand output. This carries 2 marks. This circuit symbol, it carries 2 marks. Now, the truth table for this. Truth table. Understand the truth table. There are 2 inputs. Input. There are 2 inputs are there. One is A, the other one is B. 2 inputs. And intermediate output, that is A plus B. This is intermediate output, A plus B. Then grand output. The grand output is Y is equal to A plus B bar. This is grand output. Option number 1, number 2, number 3, number 4. Okay. Now options. Which are all the options are existing? We have to write. Both are 0. One is 0, the other one is 1. One is 1, the other one is 0. Both are 1. A plus B I supposed to write. A or B. A or B. 0 plus 0, 0. This is intermediate output. 0. 0 plus 1, 1. 1 plus 0, 1. 1 plus 1. Should not write 2. We have to write it as 1. This is off, on, on, on. If you are feeding as an input for the NOT gate input as 0, then the output is equal to 1. This is on. That is the meaning. If you are feeding as 1 as an input, you will get 0. This is off. This is off. Here also it is off. So therefore, in this case, in the case of a NOR gate, output is equal to 1. In the case of a NOR gate, output is equal to 1, provided if both the inputs are 0. If both the inputs are 0, output is 1. If any one input is 1, then the output is equal to 0. So this is the basic idea under NOR gate. NOR gate and NAND gate, they are called by the name the universal gates. These two are called by the name the universal gates. NOR gate, NAND gate are called by the name universal gates, because using that universal gate, we can get any other gates. We can produce any other gate by using either by the NAND gates, not one gate, using the 2 or more number of NAND gates in different circuits that we are connecting. You are going to get the AND gate, OR gate, and NOT gate. So therefore, NOR gate and NAND gate and NOR gate, these two are called by the name universal gates. For about 2 marks question, if they are asking why they are called by the name the universal gates, NAND gate and NOR gate, why they are called by the name the universal gates. These two gates, if you are using in different combinations, NAND gate, 2 or more number of NAND gates in different versions, if you are using, we can produce the other gates. NOR gate also, 2 or more number of NOR gates, if you are connecting together, we can get, even in the case of OR gate, we can get, or inverter gate, we can get, or AND gate also we can get. Therefore, NOR gate and NAND gate. NAND and NOR, these two are called by the name universal gates. So this is the one small chapter that I have finished. Tomorrow onwards that I will take up digital electronics is over. Then solid state electronics that we are supposed to teach. Carefully you have to listen that one. Okay, if you are already having some SSLC physics, do you have the 10th standard physics? Just you go through that. Semiconductor physics, just you go through that, PN junction, P variety, N variety, all these things. I will start with the basic. If you are having that book, just you go through that. Okay, otherwise also no problem, but take it seriously about your online classes, because colleges reopening date, we don't know when they are going to start the colleges. Therefore, take it seriously about the online classes. Whatever the portions are covering, okay, go through that. Right, understood?